Yesterday we started talking about derivatives, which are instantaneous rates of change. The slope at a point, not the slope through 2 points, the slope at a point. Okay? And to find the derivative, it is the limit of the secant line slope. So the limit as h approaches 0, that difference between your x values, that goes to nothing. In other words, as one x value slides towards the other x value, your slope becomes a tangent line slope. Yes, ma'am?
We did x squared yesterday.
Yes, we did. It's not going to turn out different, but I'm going to work through it because I feel like there were several questions.
Okay.
So I don't think this will hurt you to go through this one, and we'll extend it. We'll do other examples, etc.
Okay, do I need to write this one down? It's already
It's up to you.
Recent it.
It's not going to come out any different if that's what you're asking.
Yeah. Okay.
So f of x is x squared here. My formula is this right here. Yes, you need to have that memorized. I've said that before. The limit as h approaches 0 of f of x plus h minus f of x all over h. Our f of x for this problem is x squared. Okay, now let me review function notation with you a little bit, something I didn't do yesterday that I wish I had. So here we go. Function notation, this f is illustrating squaring the thing you plug into it. Okay, that's the x value is just holding the place. Another way to write f would be with an empty set of parentheses with a squared outside. So now here's my question. In my formula, we're going to need f of x plus h and f of x. Those are the two parameters that change from one problem to the next when you're finding the derivative by the limit definition. So, f of x plus h. I have f of x. What's f of x plus h?
X plus h squared.
X plus h quantity squared. Very good. How did you find that, by the way?
Because I'm smart.
Yeah. Why? Like,
I know.
What'd you do? Find that.
Plugged it in.
Plugged what in?
The x plus h.
The x plus h. Plug that into the x position in your original function. So when you are finding f of x plus h, you change the x in the original equation to x plus h, and parentheses are probably going to serve you well. Okay? So now we need to actually use these two things to evaluate this derivative. Here we go. F prime of x is going to equal the limit as h approaches 0. Please don't forget that part. That's pretty important. That's what makes it a tangent line, not a secant line. Okay, that's what makes it a slope at a point, not the slope through 2 points. Limit as h approaches 0, and then I draw a big fraction bar and I put a subtraction in the top and an h on the bottom because those two things do not change from one problem to the next. They're the same. Okay? And I'm going to leave it like that for right now and go to the next line. On your paper, you don't need to, but because it's the first example we're doing today on the derivative, it might help you to see that template every time. And what we need to put in the first blank is f of x plus h. In the second blank, we need to put f of x, and we're probably going to want some parentheses at some point in this subtraction right there. Okay, maybe not for this problem, but for other problems. When I do that for this problem, I get the limit as h approaches 0 of my f of x plus h is the same thing as what for this problem?
X plus h squared.
X plus h, the quantity squared. Very good. What's f of x?
X squared.
X squared. Okay, so the limit as h approaches 0, I should probably have figured out what this is equal to. I should have expanded that in some mumble space. So what is x plus h quantity squared FOIL?
X squared plus h, or 2x, hx, or whatever, plus h squared.
Good. X squared plus 2xh plus h squared. The only reason we have to FOIL right now is because my function was squaring. Okay, you won't have to do that every time. Sometimes it'll be more complicated than that. You work with what you're given, and it depends on the function you're working with. Okay, so the limit as h approaches 0 of This now is the same thing as x squared plus 2xh plus h squared minus f of x, which is x squared, all over h. Now yesterday we skipped a few steps, and I'd like to not do that as much this time. Okay, so what can I do? The x squareds can cancel out. That's a very important thing. Okay? That will allow me then to have the limit as h approaches 0 of, I can take an h out of everything that's left in the top. Let me do that with you. So that gives me 2x plus h when I factor out an h from the top. And it's still all over h. What happens?
H's go away.
That's the magic right there. The h's cancel out. If the h's didn't cancel out, I'd be up a creek without a paddle, because that would mean that I still have 0 in the denominator when I try to evaluate the limit. Remember, right here, you could have evaluated the limit except you get 0 over 0. That's bad. That's indeterminate. We don't know what that equals. Okay? So therefore, the limit as h approaches 0 of 2x plus h is what I get.
And then you can plug in 0.
Now I can plug in 0 for h. And when I do that,
if the limit is 2x,
I get that my derivative, my f prime of x, is 2x plus 0. So f prime of x equals 2x.
is that how you want to like write it out, like when we're writing it out, like not the limit, you want the derivative?
You don't want the limit notation anymore
Okay.
when you evaluate. So when you plug the thing your h is approaching in, oh boy, don't write the limit notation anymore. Raymond,
Okay.
would you close the blind that's way up, because there's a glare on the video, and I think it might be coming from that. We'll see. From one of the two. There it is. That's better. Thank you. Okay. Now, what did you just find? You obviously found the derivative, but what does that represent? What is that?
Is it like where the graph meets or something?
Not exactly. I don't think.
No? Oh.
What is 2x? Anybody know what we found? Okay. What did we find?
The instantaneous?
Yeah, it's the instantaneous rate of change, the instantaneous slope. We found the formula for the slope at any x value. And when I say at, that little preposition is really important. That means it's at one point, not between 2 points. So the formula for the slope at any x value on y equals x squared. That's what you found. So if I asked you what's the slope of the tangent line at x equals 3, can anyone tell me? What's the slope of my tangent line at x equals 3? 6. Very good. And by the way, the notation for that, this is totally a different extension. This is not at all, I didn't give you this to begin with. I just pulled 3 out of the thin air. Okay, so I'm now saying find f prime of 3. That's asking you what's the slope of the tangent line at 3. Okay, and you gave me the answer of 6 because you plugged 3 in to your derivative for x, and you got 6. Now let me ask you a question. Over here, on my graph, if my x value is 3, let's say it's over here somewhere, okay? So on my function, I'm way up here. I'm hitting my function way up there. Does it look like my slope of my tangent line would be 6?
Yes.
At least it's positive, and it's a pretty strong positive. Pretty steep line. So it makes sense that my slope could be 6. Okay? So what you found kind of makes sense. If I asked you to write the equation of the tangent line, that's where we're headed. If I asked you to write the equation of the tangent line, you could theoretically do it at this point. You probably need some review of some other skills, but we could theoretically do that at this point. So finding the derivative is finding the formula for the slope at any given point, any given x value on the curve. That's what you found. Okay. What do you think?
I like it. I just see it.
That's a good thing. Yeah. Okay, let's do another one. Before we go on, I have a question. If I have the equation that's related to this one, let's call it g of x. So now instead of all that, let me put it right here, where I have some space, okay? Let's say that this is an extension of that example. So that part's A, this is now B, all right? Let's say that g of x equals 3x squared. Yeah, let's put it plus 3 to begin with. I changed my mind on which thing I wanted to do with you first. So g of x equals x squared plus 3. I'd like you to see if you can make a conjecture or hypothesis about what g prime of x is going to equal. I want all brains involved. G of x is x squared plus 3. G prime of x is asking me for the formula for the slope at any given point on the curve. So x squared plus 3, how does that relate to x squared? What does it do to it? Maybe I should say, how does it transform x squared? It shifts 3 which direction? Left, right, up, or down?
Right. I was confused.
Because the adding 3 is happening after this. Okay, now I'm going to give you time to think. What's the derivative of g of x? So what's the formula for the slope at any point on the curve of x squared plus 3? I don't know what you're saying. Thank you. It's still 2x because you have not changed the shape of the graph. All you've done is shifted the graph up 3. Did that change the slope of your line at any point? It changed the location of your line, but who cares? The slope of the line hasn't changed. So the derivative of x squared plus 3 is still going to be 2x. So adding and subtracting a number outside of the square doesn't change your derivative. And that is one of the rules of differentiation, but you just understood it. So you don't have to memorize that. Okay? Now I want to give you another example.
So it's 2x plus 3, right?
No, it's just 2x.
2x? Oh.
Because your slope hasn't changed, the location has changed, but we can figure that out when we write the equation of the line. Okay?
Oh my goodness. Look right up.
I didn't see that.
I'm not recording class or anything.
Thank you.
That's all right.
All right. I'm going to put another one here. Part C. I don't want to use H. And there's still probably bad, but we'll go with it. M of x equals 3x squared. I would like to know if you have a hypothesis about what m prime of x is equal to. You might want to think about the transformation. What does 3 multiply do to my function?
Makes it go over, right? This one shifts it, like right or left? No?
Adding and subtracting shifts it left, right, up, and
Oh,
down. But where you add is what changes which way you go. But we're not adding anymore. Now we're multiplying. What's that do to my function?
Flip it? No.
It can if it's negative.
Negative, right?
It's not negative.
Does it go up? Like up? No?
But we said it didn't shift.
Oh,
Is that what you mean? Bigger, smaller.
Yeah.
So what does multiply? You guys are like communicating with each other. What are you thinking?
I was supposed to
Talk me
like,
through it. It makes it thinner.
like 6x
Okay, it makes
squared?
it 3 times as tall.
Be 6x squared?
3 times as tall. So 6, I like the 6. I don't know about the x squared.
Oh. Oh, 6x?
6x.
Okay.
Because you're making the slope 3 times as steep. You made the graph 3 times as tall, so your slopes should be 3 times as steep as they were before. So the formula for slope at any point on 3x squared is going to be 6x. Again, I am not teaching you any shortcuts here. You're just using your reasoning of transformations and how the graphs are transformed to understand the rules of differentiation. What the shortcuts do for you, which we're not going to learn today, maybe not even this year, is teach you how to get from here to here. Sorry, here to here in one step.
And then the rest is just
We're
kind of
not
like
learning
plugging.
about why.
Because you need to understand the limit definition of the derivative first. You need to understand that it is the limit of a secant line slope, and you need to be able to use it. Besides, it's good practice with function notation and evaluating. So now I'm going to give you another one. Or am I? No, I'm not. I'm going to stop there.
Bye.